Well, dear students, in this video we will discuss about Newton's law of cooling. Cooling means one way the heat is transferred through convection. It is regarding radiation. When a hot body radiates heat, then how does this depend upon temperature difference of environment and that of body. Stephen Law also tells you, Stephen Boltzmann law also give you the heat radiated per unit area per unit time proportional to square of fourth power of absolute temperature. What is Newton's law of cooling? The rate of loss of heat or rate of cooling of a hot body is proportional to the temperature difference of body and its environment, provided the difference of temperature is small. Rate of cooling at higher temperature generally determined by Stephen law, though that is applied at every temperature. Stephen law can be applied at every temperature, but when body is at low temperature, means its temperature close to temperature environment, then this law also hold good. That is, we can say mathematically dq over dt proportional to T minus T0, where T0 temperature of environment, T is the temperature of body and T0 is the temperature of surrounding. So this law is true only when temperature difference is not large. We can prove this using Stephen law also. We can prove it. So, proof of Newton's law of cooling. From Stephen's law. Stephen's Boltzmann proof of Newton law of cooling from Stephen law. So we know from this law, from Stephen's law, Stephen's Boltzmann law. Rate of loss of heating, cooling, rate of loss of heat, or rate of cooling delta Q upon delta T is equal to sigma EA T minus T power 4 T0 power 4. A is the area of body, E is the emissivity with respect to black body, sigma Stephen constant. Now let T equal to delta T plus T0 means T minus T0 delta T, temporary difference, and delta T is very much or delta T equal to T minus T0 is small. ये कंडीशन है, तो we can write here delta Q upon delta T equal to sigma EA bracket T0 plus delta T to the power 4 minus T0 power 4, or delta Q upon delta T sigma EA. I take T to the power 4 common, so here it will be 1 minus plus delta T upon T0 to the power 4 and minus 1. T0 to the power 4 has been taken out. Here students are facing puzzle how it is possible. It is like that if A plus B whole square is there. You can take A outside, so it will be square 1 plus B upon A whole square, like that. Now here since delta T upon T0 is less than 1, क्योंकि डेल्टा T बहुत छोटा है, so by binomial expansion, so hence dq delta Q upon delta T equal to sigma EA T over 4 1 plus 4 delta T upon T0 minus 1. Actually, if x very much less than 1, then 1 plus x power n. I have told many times this hold true by binomial expansion. This one cancel, so we get here delta Q upon delta T is equal to sigma EA or T0 to the power 4 into 4 delta T upon T0, or it is sigma EA T to the power 4 and 4 into delta T. 3 power. Since environment temperature by losing heat to it from the hot body does not change, environment temperature does not change, so this whole thing constant. So delta Q upon delta T equal to, I write some K delta T, small k, let me write small k. So this is the decrease rate of loss of heat. So the cooling law, Newton cooling law can be proved using Stephen law. Now, how does the temperature decrease with time? So we have to see this thing. How does the temperature decreases with time? What is delta here? Now this equation tell you that heat loss per unit temperature difference kT. Now loss is taken negative. If we assume that loss is negative, so we can write this equation also as minus delta Q upon delta T equal to K into T minus T0. T is the temperature of hot body at that time, and T0 temperature environment which remain constant. So now let temperature of body decreases from by delta T. Now we want to see how does the temperature decrease with time, यानी कि rate of change of temperature. This gives you rate of loss of heat. So how does the temperature decrease with time? अब हमें ये देखना है. तो उसके लिए this K constant, small k sorry, this K constant depends upon nature of body and surface area. Now let mass of body be small m, specific heat small s, then heat lost for delta T decrease, loss when temperature decreases to by delta T, then delta Q minus ms delta T, or putting this value of delta Q here, we get, let me equation 1, putting this value of delta Q in 1, ms delta T upon T is equal to minus here K into T minus T0, sorry, or delta t upon small delta t k upon ms minus t minus t0. Here delta t is the degree temperature, delta t is the time interval, and hence now, or we can write that delta t upon delta t is equal to minus capital K t minus t0. K is equal to capital K equal to small k upon m into s. It depends on again on area and nature of the whole body. Now integrating both sides. And we write it dt upon t minus t0 is equal to minus k into delta t. K constant है. There is formula of integration bx upon x is equal to log base ex. E is exponential series. Value of p I have told 9 times 2.72. So we get it as log base e t minus t0 is equal to minus kt plus c. C is constant of integration which can be obtained by applying initial condition. C is constant of proportionality. It can be obtained. It can be obtained by applying initial condition. What is that? That is collect at t equal to 0 temperature of body is T dash. Then T log base E T dash minus T0 is equal to 0 plus C. So C is equal to, that be equation 4. Putting this value of C here, we get log base E T minus T0 minus kt और plus log base E T dash minus T0. We have put this value of C here. Now we can write this as log base E T minus T0 minus log base E T dash minus T0 is equal to minus kt, or log base E T minus T0 upon T dash minus T0. There is formula log m minus log n is equal to log m upon n. Using that formula, the video will go somewhat longer. Please don't get tired. KT, or you can write here T minus T0 equal to T dash minus T0 e to the power minus KT. This shows that this equation shows that temperature of a hot body decreases exponentially with time. Now, there is one equation here. हमने निकाला था ना. Now, we can plot here two graphs. There is one equation log base E T minus T0 is equal to minus KT plus C. If we plot graph between T and C, actually there is equation y equal to mx plus C. Comparing it with, this is y. This whole thing is y. X and T, C constant. We get a graph here. This has been asked in one competitive exam. Time T, log base E, T minus T0. तो ग्राफ विल बी स्ट्रेट लाइन लाइक दिस, क्योंकि स्लोप नेगेटिव है. नाउ इफ वी यूज दिस इक्वेशन एंड प्लॉट द ग्राफ बिटवीन T and temperature of hot body, so it is T dash initial temperature at T equal to 0. The graph comes like this, exponentially. This shows that initially, when body was at high temperature, the temperature decreases with time sharply, and then it decreases gradually. Now, if I take here temperature T1 and this is T2, corresponding to points P and Q, and this is the time T1 and T2. Then here, from this graph, minus T2 minus T1 upon T2 minus T1 can be written as T1 minus T2 upon T2 minus T1 delta T. So if we use this in equation, there was equation minus dt upon T equal to minus K T minus T0. We take this thing here, so we get here T1 minus T2 upon T2 minus T1 is equal to K into T minus T0. T is the temperature body. During this interval time, average temperature of body during interval T2 minus T1 is equal to, is T average equal to T is equal to T1 plus T2 by 2. T1 plus T2 is so here we can write T1 minus T2 upon T2 minus T1 is equal to K bracket T1 plus T2 upon 2 minus T0. Here using this we can find out fall of temperature in given time interval. Fall of temperature in given time interval. Thank you.